head. He went to Harvard, so he thinks highly of himself. You know how it goes. It's okay to laugh, by the way. It helps you grow. Kidding. Kidding, YouTubers. I'm kidding. All right, so the first step is we want to ask ourselves a research question. And a research question is said a specific way. It's how does blank affect blank? In that first blank, we're going to talk about the independent variable. The independent variable, or the manipulated variable, same thing. You're going to need to know both names, so keep that in mind. The independent or manipulated variable is the one that we change on purpose at the beginning of the experiment. So in here, we talk about the independent variable. In the second blank, we're going to talk about the dependent variable, what we're measuring after the experiment. And there's three types of variables that we could possibly have. We can have constants. We can have the independent, let me get this written down, hang on one second. It's a little hard to write and talk at the same time. Independent, D-E-N-T, slash manipulated, and then the dependent, slash responding variable. Man, I had to record every class. You guys are so quiet. This is great. So, hold your questions for just a moment and I'll answer them. So, a constant is just whatever stays the same in the experiment. We're going to have more constants than anything. So, stays the same. The independent or manipulated is what we change at the beginning. And then the dependent or responding is what we measure in the experiment. So, I want you guys for the next 30 seconds or so, turn to a couple of neighbors, review this with each other. Go.
What do you think the constants does? The constant stays the same.
And we're back together in 3, 2, 1. Question.
So on the constant, so the independent variable is kind of like a constant? Or is that a little different?
No. The independent is just something that we change on purpose at the beginning. A constant is things that would stay the same. So if we're like testing the different types of paper for paper airplanes, a constant, we would want the wind to be constant, for example. I mean, we can't control the wind, but we want to do it under similar conditions. So, moving on to hypothesis. A hypothesis is just an educated guess or a prediction. It's a guess or a prediction. It's us saying, you know what, I think in this case, this is going to happen. Or if you change this, then that's going to happen. It's us telling whoever's listening, or writing down on our paper, our prediction, our guess as to what's going to happen in the experiment. And we always write it a specific way. If, then, and because. After the if, we talk about the independent variable. We talk about the state or the condition of the independent variable. In other words, what is it like at that time? So we could say something like, if we use heavier paper, and then we go on to talk about it. So we talk about the condition of the independent variable. So it's the condition of the independent variable. After the then, we talk about the dependent, the responding variable. So if we made the paper heavier, then we would make a guess what would happen then. Say, well, then I think it would go farther, or then I don't think it would go as far. So then we talk about the dependent variable. So we talk about the effect. Remember cause and effect? Yeah? Good. Effect on the dependent variable, or what's the effect on what we're measuring. And then finally, the because is just the why, or an explanation. You're explaining, explanation, there we go. Oh, sorry, I know it's heavy, you'll be okay. So, why, or the explanation as to why you think that's going to happen in this experiment. So, take 30 seconds, talk to your neighbors, and review hypotheses. Go. Yes, sir. What's your
Because like the information
Is a guess or prediction. So practically it's
And we're back together in 3, 2, 1, 0. All right. Next, we're going to move on to the material list. Now, the material list, there's 2 questions that you want to ask yourself. What kind or what type, and how many? Because if I just say, for our paper airplane experiment, if I just say paper, well, what kind of paper? I mean, do we want butcher paper? Do we want construction paper? Do we want toilet paper? You know, there's a whole lot of papers that we can use, right? So you need to specify what kind of paper and how many. So I would say 8.5 by 11 copy paper, and you would need 1 sheet, and then say an 8.5 by 11 piece of construction paper. So you want to make a detailed list telling you exactly what kind and how many of each thing you would need. And then you just do it like a grocery list. You put down however many of whatever it is that you need for your experiment. Okay? That's pretty straightforward, right?
Yes.
Just basically like a grocery list, but you know, you want to make sure that you get the Campbell's soup and not just, you know, the generic soup. So, let's move on to the next one. After the material list comes the procedure. Now, remember when you guys tried to help me make a sandwich?
Yep.
Yeah, that was the procedure, okay? That's what we were talking about then. So, procedure. For the procedure, what happened when you guys didn't give me very detailed instructions?
You made mistakes.
Yeah, I looked like an idiot, right? Okay, that's why we need to give detailed instructions, so that way anyone can do this, they can redo the experiment exactly how we do it. Okay? So the procedure is just in order exactly how to run your experiment. How to run your experiment. I apologize for my handwriting. I thought I was going to be a doctor for a while, so just one of those habits that never leaves you. Now, so for 30 seconds, talk about the differences between the material list and procedure, and what questions you should ask yourself when you're writing those. Go.
Use the material.
Bake a cake. Eggs, milk, butter. But what kind of eggs? Sugar. Chickens.
White chicken eggs because they're white and they're brown.
And roll
I
back
took my
together in
phone
3,
off because it always
2, 1, 0. Nice. Alright, so now, after you run the experiment, because you actually run the experiment in between here, run experiment. So after you're done writing down your research question, hypothesis, material list, procedure, then you run your experiment. Now after you run your experiment, you're going to have data, or data. I don't know what the official pronunciation is. I've heard both. I don't think it really matters. Anyway. So, you can have a data table and you're going to make a graph, usually. So the data table, how many of you guys like baseball? There you go. Yeah. So a data table is just like a scoreboard in a baseball game. And unfortunately right now, if you're a fan of the Mariners, on the scoreboard you're going to see a lot of zeros.
Wow.
Okay, for others, I don't like it, it's just the truth right now. So, and then you have the other team score right there. So that's a data table. So you go, here's the Mariners, and just for the sake of writing, let's say they're playing the Orioles. Okay? So, then what you... I'm getting some nasty looks right now. Okay. Then, you take this data here, and you're going to turn it into a graph. So you get your big capital L drawn there. And there's a few things that every graph needs. You need your title. That tells us exactly what the graph is about. And then your x-axis, you're going to label that. And then you have your y-axis that goes up and down this way. And you're going to label that. And you also need to scale it. In other words, you want to make sure that you have enough room so that you can fit all of your information in there. So if you're counting by ones, let's say, and one of your pieces of information, one of your pieces of data is like 57, you want to make sure that you have room. So maybe instead of counting by ones, you count by fives. So you're scaling it so that all the information fits on there. Now for our purposes, we're usually going to use either bar graphs, like this, or we're going to use line graphs. Bar graphs we use when we're counting up something. Line graphs are typically going to use when we're talking about time. And if we're talking about time, time is always going to be, with rare exceptions, time is almost always going to be going across the bottom of the graph. Nod your head if this is making sense so far. Good. All right. Now, with one other person, take 30 seconds and discuss data tables and graphs, what you learned, what you know, and maybe some things that trip you up, so you can help each other out. Go.
Let's say you how many so practically like if you line graphs are for time and usually for time.
All right, and we're all back together in 3, 2, 1, 0. Nice. All right. Last part here is the conclusion. Actually, second to last part, because there is one other thing I want to mention real quick. So 6, back here is our conclusion. And you're going to hear these 4 letters over and over and over and over and over again from me. R, V, D, O. RVDO. Okay? In fact, let's say that a couple of times. Go. RVDO. One more time. RVDO. Wonderful. You guys are amazing. All right. So, in the conclusion, we're talking about what we learned or noticed. What we learned or noticed in the experiment. And now R, red, in this case, this stands for restate hypothesis. It's just a fancy way of saying you just say your hypothesis again. The V, violet, or purple, again, I think they look a whole lot alike. The V stands for, excuse me a second, my brain is turning off. The V stands for valid. And what I mean by that is, was your hypothesis right? Was your hypothesis a good guess or was it not so accurate? So, was your hypothesis correct? And that's what you talk about next. The D, dark blue, stands for data. And you're going to talk about your highest data In this case, like for the game, the highest score being 3, so your high data. Your lowest data, the lowest score. And then finally your average. Usually that's going to be your mean, where you add them all up and you divide by how many pieces of data you have. And then finally the O, the orange. This is where you talk about if you observe patterns. So maybe when you're flying your paper airplanes, you're like, you know what? The heavier the paper we use, the farther it went. And that's when you would say, I noticed that when we used heavier paper, the plane would travel farther. Making sense so far? Yes. Yeah. Now, this is one cycle, but here's the thing. When we get to a conclusion, maybe we want to make the airplanes even better. We can just make adjustments. And then start over and ask yourself a new research question. So this is scientific inquiry, scientific method, or the cycle of science, as I like to call it. Thank you.